Hey students, welcome back to Unit 1, Chapter 1, and this is just Part 2 with measurement here, okay? So volume of a solid. It's the amount of space occupied by the object. Well, how do we measure the volume of a solid? Well, we use a ruler, okay? But what we're looking for on the ruler is not the inches side, we're looking for the the centimeter side. All right, and then once we do length times width times height, we have cubic centimeters, which means centimeters to the third power up here. All right, length times width times height. That would be 10 times 8 times 9. Length times width times height. So again, the length is 10. The width is 8. The height is 9. All right, when we do 10 times 8, that gives us 80. 80 times 9 is what? 720, I believe. All right, so that would be the total volume of this solid, but there's something very important missing from that number. Okay, we always must put the unit. So it's 720 centimeters cubed. 720 centimeters cubed. Oops. 9. And with all these numbers, it would have been meters. Meters. And specifically, centimeters for each one. 10 times 8 times 9, 720 cubic centimeters. When I say cubic, that is 720 cm to the third. All right, that's the volume of a solid. Length times width times height. Now, to get the volume of an irregularly shaped object, we have to use something called water displacement. Okay, now, when I say irregularly shaped, that's something that does not have a defined length, width, and height. Therefore, what I do is I measure in a graduated cylinder a certain amount of water, a starting point. So in this one, it looks like it's at 200. So the amount of water without the object is 200. Okay. Remember, we're looking at the meniscus, which is the curved surface of the liquid. Then I put the object into the water. When I do so, the water level does what? Does it rise or go down? It should rise because we just put a bunch of mass inside of this. Okay, so now we look at the measurement with the object, which is about 275 or so. All right, we have 200 without the object, 275 with the object. We're looking for the difference. So we do 275 minus 200 gives me the volume of the irregularly shaped object, which in this case would have then been 75 milliliters. 75 milliliters. Mass. Okay, mass is the amount of matter in an object. The SI unit for measuring mass is the kilogram. Okay, 1 kilogram is equal to how many grams? 1 kilogram equals 1,000 grams. 1 kilogram equals 1,000 grams. 1 gram equals how many milligrams? 1 gram is going to equal 1,000 milligrams. All right. The instrument that we're going to use to measure mass is what we call the balance. This one right here is a triple beam balance. All right. If you're not sure how to use it, make sure that the mass goes into the notch. Okay. Each one of these masses goes into the notch as you slide them on the triple beam balance. So you place the object on the balance. You slide the hundreds mass first. Okay, the hundreds is the largest one. All right. Once, and it's kind of hard to explain just by telling you about it, but once this one is set in the correct place, we're then going to go to the tens. Okay, and once this one is in the correct place, we're now going to go down to the ones. Then we're going to add them all together. You add this one plus this one plus this one. This says 300. That says 70. So 373, looks like 373.4. It's not 0.5. 0.5 would be about right there. 0.4 kilograms. All right. Now let's look at the density equation. All right. So to measure density, that's the ratio of mass per unit volume. The ratio of mass per unit volume. So in SI units, density, the unit here, if it's a liquid, is the gram per milliliter. If it is a solid, it is the gram per centimeter cubed. All right. What is the density if I give you volume and mass? So density equals mass divided by volume. Mass equals density times volume. And volume equals mass divided by density. The way I like to remember this, I draw it the way it is there, okay, with the circles. And then in between the D and the V, I like to put a little X. That way I know that you multiply there. And I don't even write the division sign above the D or the V, but I just think of this line as a division sign, that yellow line there. So if I want V, volume, I just do mass divided by density. If I want density, I do mass divided by volume. And we're always going to give you at least two of the three here. And lastly, if I want mass here, I do density times volume to get mass. So this first equation on the left here, we're looking for the density. All right, and density is mass divided by volume. Okay, density is mass divided by volume. If I do 10 divided by 5, because I have 10 grams, 10 over 5 equals what? The density should be 2. I like that too. 2. Okay, since mass is up top, that's where grams are, over my volume, ml. So the answer to this is 2, and then don't forget you must have your units. Grams per milliliter. 2 grams per milliliter is the density. Now let's look at this, the other side over here. Let's look at this side. Let's do this equation. All right, so they gave us density here, but they did not give us volume. So I'm looking for the volume here. To get that, it's mass divided by density. All right, my mass is 10. My density is 50. 10 divided by 50 is 1/5, also known as 0.2. All right, so I'm just going to say 0.2. It's the same thing as 1/5. Okay, mass is in grams. Density is in grams per centimeters cubed. Oops. cm to the third. Okay, and therefore the grams are going to cancel out. My volume is then 0.2 centimeters cubed. All right. Manipulating this formula right here, okay, is very helpful, and you'll be able to figure out any equation that I ask you when it comes to density. You'll be able to figure out volume, mass, or density. All right. After that, the key is just making sure you have the right unit there. If it's volume, you're going to have milliliters. If it's density, you're going to have grams per centimeter cubed or grams per milliliter. If it's mass, you're going to have grams. All right. I want you guys to look at this. It says guess. Guess stands for given, unknown, equation, substitute, and solve. All right. So when you go to solve an equation, I want you to look at what you're given. So first identify what has been given to you in the equation. What is your unknown? Like, what are you trying to identify? What are you trying to solve for? Then, what is the equation you're going to use to solve this problem? Then you substitute the numbers in for the letters in the equation, and lastly, you solve it. You plug it into the calculator, plug and chug, you get the answer, and don't forget to use your units. All right, let's do this example. What is the density of a piece of wood that has a mass of 25 grams and a volume of 29.4 centimeters cubed? We're looking for what here? Density. Density is grams per centimeter cubed. So we already know that our units in the end is going to be G over cm to the third, grams per centimeter cubed. And we're going to do density equals m over v, mass over volume. Mass is 25. I'm going to plug it in. 25 divided by the volume, 29.4. All right, once you plug that into the calculator, you're going to get less than 1. I'm just going to guess here it's about 0.9. Okay, something, grams per centimeter cubed. All right, so it says a piece of wood that measures 3.0 centimeters by 6.0 centimeters by 4.0 centimeters has a mass of 80 grams. What's the density of the wood? Would the piece of wood float in water? So the first thing we need to do is get the volume of this piece of wood. Very easily, we do length times width times height. 3 times 6 times 4. 3 times 6 is 18. 18 times 4 is 72. Okay, so I write down 72. All right, and that is our cm to the third. Cm to the third. Now I have a mass of 80. Okay, so my density again is mass over volume. I have my volume 72, my mass is 80. I do 80. I don't like that 80. 80 divided by 72 equals, what does 80 divided by 72 equal? Your answer should be 1.11. Okay, and that is the density, which is grams per centimeter cubed. Now it's asking, would this piece of wood float in the water? Does anyone know what the density of water is? The density of water is 1.0. And since this piece of wood is, again, 1.1, 1.11 is greater than or less than 1.0. It is greater than 1.0. Therefore, if this is water, H2O, and this over here is our wood, the 1.1, this density being higher than water will cause this piece of wood to sink. Okay, things that are less dense than water will float. Things that are more dense than 1.0 will sink. All right, so here's our next problem. Let's go ahead and work this one out. Here's our next problem. Let's go and work this one out. Our third problem. Now this right here, I just want to show you that water is right here, 1.0 density, grams per centimeter cubed there. Let's work this one out. The last few things, time. Time is the interval between two events. The SI unit for time is seconds. All right, the instrument that we're going to use is a stopwatch for time. Temperature, we're going to use a thermometer, and the SI unit for temperature is Kelvin. All right, measures how hot or cold something is. Here's the metric conversion challenge and the second page to the challenge.